Hello. So here the problem number 6. In problem number 6, we need to find the longest common sequence of the two given strings. And what does it mean? It means that uh, comparing two given strings, we need to find common letters, and letters should be in a subsequence order, but the letters are not required to be in a consecutive order to each other. So what does it mean? For example, we have these two given strings as an example, and the common letters from these two strings are, if we will consider the letters from the beginning of each string, so we will see that first common letter is A, then it's D, and then it's H. And how we're gonna find it in our function? So in order to find the longest common subsequence from the two given strings, we need to create a matrix of these two strings. And I already created the matrix here, just not to spend my time on filling all the numbers in this matrix. So for example, one string goes to the top of the matrix while another is on the side. So basically one is for columns and another for rows. And always when we fill this matrix, the first elements of this matrix, I mean the row at the 0 index and the column at the 0 index, should be filled out with zeros, just zeros. You see the first row and the first column are all zeros. But then starting from the first letters of each string, we have to check if the letters, the first letters, are equal to each other or not. In case it's equal, we have to look at the top left side cell and increment it by 1. So top left side cell from our position where two letters are equal to each other, we look to the top left and increment it by 1. So it's 0, incremented by 1, it's 1. So when we go to the next character, it either can go to the right or to the bottom. And let's go to the right. And if the characters are not equal to each other, then we will look to the top and to the left and take always the maximum number. So in our case, the maximum number on the left side, so we're just filling out our position with the maximum number from left. So and for the rest positions will all also fill out with the 1, because the letters from two strings are not equal to each other. So we're just, each time we're taking the maximum number from the left. And again, when we go to here, we see that still the letters are not equal to each other. In that case, we are populating our cell with 1, because at the top we see that it's number 1, while at the left we just have a 0. So we're populating it with the maximum value, which is at the top. So again, we'll go to the right, and each time we're just populating it with 1, because there is no common characters in this line between two strings. So we go to the third row. Again, we are populating it from the top. Then we're just populating either from top or bottom, like it doesn't matter. Since they're equal, we just can take one value from the top or left side. So when we go to here, we see that the characters from two strings are equal to each other, so it's a D. In that case, we look to the top left cell, which is 1, and incremented by 1. So 1 plus 1, it makes 2. So in here we're filling out our matrix with 2. The rest again it's 2 2, so here it's just 1 1 1. Here we're populating it with 2 because the maximum is on the top, so we're populating with the maximum value from the top, not from the left, which is 1. So the rest we're populating this either from top or left. So then we go to here. We also see that the characters are equal to each other. Here we're looking to the top left and incrementing our 2 by 1 and make it, which makes it 3. So we're populating this cell with 3, and the rest we're populating just looking to the maximum numbers from the left or top. So after we reach to the last position of our matrix, from this point we also go to the maximum value. So in our case we go to the top because the maximum value, first of all we need to check the left side and the top side and go to the cell where there is the greatest value. So in our case it at the top. So at the top we go to the top and see that the common characters are h. So in this case we're just writing our h. For saving these characters in my algorithm, I will be using stack just in order to be able to append, because you see here in this matrix we go to in a back direction, so we're moving from the back to the beginning of each string. That's why I will be using a stack just in order to have the proper value of the command string. So after that, when I see that there are common characters, I go to the top left. From here I can go either to the top or to the left, it doesn't matter. So then I see that the common character is the D. I also put it to the D. Then I see that the next common character is A. So after that I will just run a while loop and pop out each character from the stack, and at the end I will just return the longest common subsequence of 2 given strings. So here there is my code. So in my code I will be returning the string, and I will be passing 2 strings. I will be taking the length of 2 strings in order to populate my matrix properly. I will declare matrix with the size bigger than the length of each strings by 1. So after then I will use for loops. One for loop is just going through each row in the matrix, and another for loop is just to go through each column of the matrix. So in here, in case I see that the index is 0, so meaning that it will be the first row or the first column, I will just populate it with 0. In other case, if I will see that the characters from 2 strings are equal to each other, then I will populate it with the, as I told you before, with the top left value from the top left cell incremented by 1, and else in and the other condition, if the characters from the 2 given strings are not equal to each other, I will be just populating it with the maximum value either from the top or the left side. So this code is just for populating, and here in the next page, I will be just taking out the longest common subsequence of the two given strings. So for that I will declare a stack of characters. Then I will run my while loop just to go through each characters in the matrix, and I will run from the bottom, from the last element, until it will reach the first element of the matrix. So it will be either index m0 or n be greater than 0. So I will say that if here I will be using indexing directly on given strings. If I will see that the characters of two strings are equal to each other, I will just push this character to the stack, and I will decrement the values of m and n. In other case, else if matrix I will be looking for the to the left and to the top cell, and we'll try to find out where the maximum value so in case the maximum value is on the left side, I will go to the left by decrementing my m value. In other case, I will just decrement my n value, just go to the next top cell. So after that, I will by this while loop I will populate my stack with the common characters, and after that I will need to pop them from there, from the stack, and return them as a string. In order to return them as a string, I will use string builder. So while stack is not empty, I will run my while loop. I will be appending letters from the stack, just popping it from the stack, appending it to the string builder. After I will take all the characters from the stack, I will just return the string builder converted to string. So time complexity of this code is, so here we have double for loop m multiplied by n. Here actually, since we are going to from the bottom to the top, here the number of operations, it's either m or n, not so, and time complexity will be O m multiplied by n plus n. So it basically means that it will be on, because m it's a number of characters in one string and n is in another. So basically the number of operations will be the number of letters in two given strings. And space, so as a data structure, here I'm just defining integers, one two-dimensional matrix and one stack. The memory of two-dimensional matrix is also multiplied by n, and stack is just it's even less than number of characters in the each given string, so the space will be also O n.